I'm going to be covering a huge topic with a lot of research behind it very quickly. So please throw questions in that chat. And even if we don't have time to get to them today, we will do our best to get back and respond to them so you can learn as much as you want about the topic. Okay, so I'm going to be using this term Allen or artificial light at night quite a bit. So there's been lots of studies on the impact of light more generally on bats. There's lots of natural sources of light and how that impacts bat behaviors, such as moonlight or what it's like when bats live in these really northern latitudes with very short nights and very long days. But today we're specifically talking about artificial light. So, what humans are doing to light up the planet, as you can see from this image taken from space. And artificial light at night, Alan, is considered a threat to biodiversity very broadly. It's impacting many species. There's impacts to plants. It's not just animals. There's studies into the impact of all of this light at night on human health. But today we are focusing on our favorite organisms, bats. If you want to dive into this topic more deeply, one really cool resource that is up to date and looking at that change in how our globe is lit up by our activities is this New World Atlas of Artificial Sky Brightness. You can put in your address and look at how bright where you live or a particular place is compared to the natural light levels. Like I looked it up, and where I live is 20 to 41 times brighter than natural light levels, and that's and very scary. And I don't even live in a really big city. Of course, our light levels have been increasing over time in the US. It's estimated that at least 50% of the land area is exposed to artificial light at night. And this is pretty sad considering at least, but only 3% of the land area is actually urban. So this is not just an urban problem, it's everywhere. This is a look at an animation of that change in light levels in the US from the 90s through today, and looking how it's just blowing up. Light levels everywhere increasing at about 9.6% per year. And annually, it's about 2% annual increase in brightness. So there are lots of sources of light. One of the major ones are from urban areas and street lights that are put out for public safety. And just that single street light is having lots of effects and causing all these different light effects. And so it's not just that area that we want to be lit, but it's expanding beyond that, depending on the light type and structure. But it's also kind of going up into the atmosphere and reflecting off the atmosphere and clouds and water vapor and coming back down. So we actually have a greater brightness on when there's more clouds because that light is bouncing off those clouds and coming back down to the planet. Other sources of light pollution come from commercial lighting of businesses, signs, billboards, those things to attract your eyes 24 hours a day. Lots of residential lighting, and that can be excessive or poorly designed lights at houses, security lights, lights from traffic and cars. All of this is creating things like light trespass, which is this light falling where it's not intended to be, and then also glare that's going to be brightness causing visual discomfort to both us and wildlife. And then all of these sources of artificial light are contributing to this broader phenomenon called sky glow. And what sometimes can look beautiful, we can see it, as we approach a city or, a stadium is lit up at night. We can, oh, wow, that went a little crazy. We have this sky glow, and it's this brightening of the night over these inhabited areas. And one of the things is that for organisms, it can mask the natural rhythms of lunar sky brightness, which is a natural cue and signal for a lot of organisms. One of the ways that we measure the impact of light pollution on dark skies is with this Bortle scale. And as you can see in this image, when we go from an excellent dark sky site, we would hope would be in like protected national parks where we are specifically keeping areas dark. We have this beautiful sky that's lit up. We can see the Milky Way, tons of stars. And as we move towards sources of light in urban areas, we see fewer and fewer stars. And to where we get to an inner city lit up sky glow sky where we're not even able to see stars in the sky. And this is not just impacting our ability to appreciate the astral objects and do astronomy, but also it's having an impact on a lot of wildlife. And not surprisingly, bats, being nocturnal, are one of those organisms that has been highly studied, and there have been repeated studies showing negative impacts globally on bats by artificial light at night in a wide range of habitats, whether that be in urban areas where we have bats that we would assume are habituated to lighting, in forested, desert, coastal environments, kind of everywhere. A lot of the studies have been coming out of Europe, but we do have representative studies from other areas as well. And just broadly, we see that artificial light at night is generally reducing bat activity and species richness. So we're not seeing as many species in an area when it's lit up, and the species that are there are not as active. They're not using that area in the same way. And there's all these different behaviors that are impacted from foraging, drinking, their roosting, their general movements, such as just commuting and looking for prey or migration. And it even has been shown to have impacts on their reproduction and hibernation. And we're not just talking about, a street light shining right down on that bat as it's trying to do something. These are even really low light levels that are still artificial, can really have an impact on bat abundance and the timing of their activity. So first, I thought we would take a look at foraging. This is one of the biggest things we think about bats out there, especially are the 70% of our bat species globally that are insectivorous, controlling our nocturnal predator or prey. Sorry, in controlling those insects that are out there, those pests. And artificial light is having a dramatic impact on their ability to forage in these areas. So we have our insectivorous bats that are being impacted by their prey selection is changing and their foraging behavior. So there's research in the US showing that these are changing depending on light in different areas. It's also delaying like the timing of things. So when they're emerging from the roost will change if they're exposed to these artificial lights. And then because they're coming out later at night, that means that they're going to have less opportunity to be out foraging. So it's reducing their foraging opportunities and potentially meaning that they get less energy that night. A less studied group and their foraging are frugivores or our fruit-eating bats, particularly in the neotropics or in Central and South America. They are also impacted by artificial light. And one study found that they're less likely to eat fruit when it is either dimly illuminated or directly under a street light. So that means that it's going to jeopardize or delay the ability of that fruit bat to eat those fruits and then fly off and distribute those seeds out and for forest regeneration and forest succession. So it's down the line, we could have long-term impacts of more tropical landscapes that are fragmented because the bats aren't able to eat as many of the fruits that are available to them because they're lit up in particularly in these urban areas. And then there's also a couple studies out there looking at the impact of artificial light on pollinators or our nectivores that are out there. And they found that while the plants weren't actually negatively impacted totally because there was some benefit of increased photosynthesis from these lights on the plants, that the pollinators were visiting the plants less. And so there's going to be less kind of sugar and food available to those pollinators and potential long-term effects of less pollinator visits and impacts on genetic diversity down the line. So when we're looking at all of these impacts, there's like immediate impacts, like what we're able to study in that moment and measure. And then we really are just having to hypothesize what are these long-term impacts? And that's something we're going to kind of keep coming back to. Another really neat study was looking at how drinking activity was affected by these artificial lights, and it was shown in both forested and desert habitats that bats were drinking less and like using these water sources less when they were illuminated. And this is going to lead me to my hot topic of debate for the day. The myth is I have heard many times that streetlights are beneficial to bats. So when you go out, especially if you live in kind of the northeastern area of the US, there are some bat species that you will frequently find feeding on insects that are attracted to those lights. So you have a light, insects are attracted to the light, the bats are like, whoo, yeah, I'm gonna go for that all you can eat buffet right there. And bats have probably been taking advantage of these insects being attracted to these lights since street lights were invented in the 1920s or so. Um, and what we have found over the years as we've studied these interactions, that it's really a subset of bat species that are using this as a resource. One of a good example of this is the red bat, either the eastern or western or southern red bats, and Lasiaris species in general tend to be fairly light tolerant and will feed on insects under those lights. Um, so what's the harm, right? These bats are getting fat and happy under these lights. It must be beneficial to them. And this is where that topic of are we talking about an immediate benefit or is it over the long term going to be beneficial? And really, the argument that hasn't been demonstrated through research yet, but is generally accepted, is that this is going to be having longer and larger ecosystem impacts on the bats and the broader ecosystem because it's giving a competitive advantage to these bats. They are going to go into super predator mode. They don't need to use all those skills and kind of, give the insects a chance. There's also the bats that aren't able to take advantage of the lights because they're more light averse. They're not going to be able to play this game. And so there's going to be kind of a competition going on here. But then another really important part is the impact on the insects. And this is a really hot topic right now as we think about the insect apocalypse and declines in insect populations globally. There really isn't a lot of research showing the long-term impacts of artificial light at night on insects, but most entomologists and researchers agree that is a major player in these insect declines because the vast majority of nocturnal insects are attracted to short wavelengths in the blue and UV ranges, which a lot of our street lights and lights have. And that's what's responsible to that flight to the light or moth to the flame behavior that where they are all attracted to those lights. And it's really falling in that like peak visual sensitivity area for these insects, and that's why they're attracted. But this attraction can cause pretty high mortality of insects due to the heat of the lights, causing them to die. They've been shown to circle until they die of exhaustion, which is pretty depressing to think about. And then they're also being caught by predators at a fairly unfair rate, right? They don't even have a chance to do any of their anti-predator avoidance. And that has even been shown that the moths that are able to hear bats and do go into what are called like these power dives when they hear the echolocation of a bat, they'll go into this behavioral response of just diving out of the sky to get away from the bat, which is awesome. And they found that fewer moths actually perform that behavior when they are exposed to LED lights. So it's not just that they're like attracted to the light and they're just sitting there waiting to be eaten, but they're not even getting a chance to use their anti-predator behaviors. So with all of this, even though there are some bat species that appear to be taking advantage of some lights, the general consensus is that those couple fat bats that are out there during the summer feeding on all these insects, it's really not enough of a short-term benefit to outweigh the long-term negatives of these lights on the ecosystem. So aside from foraging, just broadly, bats' movement is impacted by artificial light at night. So one thing is when they're just out there moving from place to place or on their daily commute, there is research showing that their daily commuting behavior is negatively impacted. They're going to stay out of areas that are lit. Essentially, those areas with light are like a road closure for them, that then they need to spend a lot more energy to go around and find other ways to get where they're going. In some areas where there are wildlife crossing structures that they hope bats will use to like cross roads and anthropogenic human-made areas. If they're lit up, bats won't use them. And in general, landscape connectivity, so patches of kind of natural habitat that may be connected. If you put up a light, you're essentially cutting it off and putting a barrier for most bat species to cross. And so this will disrupt bat activity. And the positive thing is that bats will adapt to using the dark corridors that are there. But the risk is that if we just light everything, that those dark corridors won't exist. So they will adapt, but we have to give them the options so that they can. There are different types of lights, and there's been a lot of research into the impacts of these different types of lights, and especially over time as our light technology has been changing, particularly towards our more energy and cost-efficient LED lights, kind of what was the impact of switching from these older light types. So one thing that's been shown pretty broadly is that UV emitting lamps, so ultraviolet spectrum, and I'll show up a diagram of that in a minute, attract more insects, as I was just talking about. And so because there's insects drawn to them, it's going to attract bats, some bats that will feed on them. With these older technologies. They found that metal halide lights are more attractive to bats and have higher activity than low pressure sodium street lights. And that's because um, they are going to be doing that same thing with a higher UV component in their lights. So again, they're attracting more insects, which attract bats. So it's kind of this trade-off of there's higher activity because bats are attracted to it, but not necessarily because it's good for them. And then a lot of the research is showing that it's very species specific with how bats are going to respond to different light types. So LED and mercury vapor streetlights have different responses by different species. But in general, the mercury vapor lights had more of an impact on light averse species. And then lastly, we have our LED streetlights, which do negatively impact bats and reduce kind of overall activity, and in particular, these slow flying bat species. So even though there are energy saving benefits to LEDs, they are still not great for bats. And the reason for this is because of the wavelengths that are being emitted by these lights. So I'm going to go really quick. If we have our light spectrum, lights are these different colors of lights that we see are different wavelengths. From our shortest wavelengths being in our UV to purple, blue, and then our wavelengths get longer as we go into the red and infrared or IR spectrum. And with these older technologies that really a lot of cities have really switched away from now, they had this kind of broad spectrum. You can see our mercury vapor went from low to high wavelengths, but there was a lot in the middle, but there was this high UV component here. So again, this isn't going to be attracting insects, what then attracts bats. Metal halide, we saw attraction. And again, it doesn't have as high a UV component, but it's still there. And then if we switch over and we look at LED lights, they are broadband. So this is a white light being shown here. When we have this wide range of colors being shown, that means that we're seeing white, right? So here, this low pressure sodium with the single spike right here, that light is looking more yellow orange. So when you think about your LED light bulbs going from daylight to cool white to warm white, they're just playing with the amount of these different wavelengths that are being emitted from these bulbs. And so our general white is really all the colors, but it does have more of those shorter wavelength that are attractive to insects, and we'll see how the bats respond to them as well. So remember, when we're talking about these colors, it is associated with these wavelength. And so UV, blue and purple are really short, and red to infrared are the long. And there's been research showing that color does matter. So we have, again, very species-specific responses with white light, which remember is that broad spectrum, really including kind of all the wavelengths, and green light, which is on the shorter end of the spectrum, are negatively impacting slow flying species, but red light is not. So this is where research was starting to show some promise. And another study found that red light did have negative impacts on a particular threatened species that is very light sensitive. But for the majority of the British bat community, they didn't see any impacts. So there's still research showing that red does have an impact. Light can have an impact, but red and these longer wavelengths are looking better than the shorter wavelengths for bats. Some other research specifically looking at the attraction of migratory bats to lighting was looking at green and red lights and then also warm white lights, and found that these migratory bats tend to be attracted to green and red lights, which is concerning because it could impact migratory patterns. And then the warm white light didn't really attract the migrants, but they would go and forage at them. So we have this kind of intersection of what the bats are attracted to, and then what the insects are attracted to, and then attracting the bats to go feed on the insects. So it gets complicated, teasing all these things apart. And really the hard part is the solution isn't to just turn off every single light in the world. So that's why we keep digging in and trying to hone in on what affects what. So one of the most recent studies has found that these kind of natural activity patterns of bats are less impaired by red light than white light. So there's a lot of research showing that red light is less impactful than white. And with this recent study, they had a beautiful kind of summary figure of their research that I wanted to share, looking at kind of insect abundance and insects attracted to lights, and then bat activity, and then the bats foraging. And so what they found was, there's bats and insects there when the lights are off. There are bats and insects there when the lights are red, but there's way more bats and insects there when the lights are white. And the big difference, what they found, is that the patterns of activity change through the night. So a normal activity pattern is kind of this black line where they have this peak in activity early in the night, and then it drops down and lulls, and then there's another peak in activity before daytime at sunrise. And when the white lights were on, it just had constant activity all night. So both the insects and the bats were just going all night. So this is a big shift and big change from what they were doing. So not only are they more active and attracted to this light situation, but it's going all night. And red light had the same effect, but to a much lower level. So even though red lights aren't the same as having no light, it's still much better than a white light situation. So again, what we're seeing kind of on this wavelength spectrum is that bats are really impacted by these shorter wavelengths, both with the insects being attracted to ultraviolet and white light and blue light, and then the bats also being attracted to this kind of blue-green spectrum. And then this red to infrared is really where, if we need to put out a light, we want to be putting it. So one interesting thing is that a lot of studies that are wanting to record bat behavior without impacting it, they will use infrared lights. And so to our eyes, they're beyond kind of our perception of lights. So that's why it's out here in the black. This is kind of the max that we can see out to the red. So to us, an infrared light doesn't even look like it's on. But when we record with an infrared camera, where it's all lit up and we're able to see what's going on out there, but the bats are also not impacted by it. So that's what a lot of studies are doing, or using thermal cameras, because as we can see, light is impacting behavior. So one of the frustrating things that it comes to when we're doing all this research into the impacts of light on these species is that we can't just make a general statement about how bats are impacted. And I guess this is why I love bats, is that they aren't boring. They don't just do one thing. I think our current species count is 1,482 species, and you can't generalize about any of them except for they fly, are nocturnal mammals. So we definitely cannot generalize on the impacts of light on them. So some of the generalizations that we can make sort of are in whether species are going to be light tolerant or light averse. So the light tolerant species tend to be those that are faster flying, that are out foraging and using wide open areas, and also the kind of edge spaces like along tree lines, along um, natural corridors. And then our more light averse species are those that specialize in foraging in these cluttered forested areas. So we call them narrow space foragers, and they tend to be slow flying, very maneuverable because they can just like weave in and out of between really closely packed trees, where these fast flying species like a Mexican freetail or a hoary bat or a red bat, they need a wide open space and they just go. So whether we're talking about, Europe, Asia, Africa, the Americas, these are kind of the broad generalizations that we can make, but there's also always species out there that are going to break the rules. And so I just wanted to share some of the research that I've been part of with one of my colleagues, Dr. Seawagon at Great Hollow Nature Preserve and Ecological Research Center in Connecticut. Back in 2021, we studied the impact of lights in this bat community in Connecticut because, like I said, most of the research had been done in Europe, and we wanted to know how our local bat species were being impacted. So at this ecological research center, we put out these 3 LED floodlights, like residential lights that you can go out and buy today, and measured the acoustic activity of bats in that community. And the results were not surprising, but it was a good foundation for our um, local community. And so we found, as others have, that there are more light tolerant species. And we found that silver-haired bats, eastern red bats, and hoary bats are the more light tolerant. And then our more light averse species were the little brown bat and big brown bat. Both species were reduced at least by 50% when the lights were on. So when the lights are on in this area that is not normally lit up, there is a changed community of bats that are there. The little brown bats and the big brown bats are going to stay away. They're not going to be there foraging on insects, doing their thing. They're going to go elsewhere. And so that's changing what's happening in that environment if the lights are on. The next piece of our study was how far out is this effect? So we have our 3 lights out there. So now if we move away from those lights, is there a certain place where the bats no longer care that those lights are on, like it's dark enough? So we looked at their activity kind of right at the lights, so put a detector at these places, 24 lux, so that's the light level right at the lights, and then moved out at 25-meter intervals. So looked at their activity at 25 meters, 50 meters, and out to 75 meters. And what we found was actually pretty surprising. And it was that by the point that I would feel like I was standing in a dark forested area, the bats still are perceiving that the light is out there and is impacting them. So with the big brown bats, we have this distance from the light source. So 0 is where the light is on. And then we have kind of the activity levels in these dark bars are when the lights are off, and the yellow bars are when the lights are on. And we can see that big brown bat activity was lower when the lights were on. We already saw that from our previous study. We knew that. And then we found that the activity levels, although they were generally lower, it wasn't statistically lower, out at these greater distances. But so those big brown bats really are just carrying right at the light. However, little brown bats are very sensitive. Right at the light, it was like zero activity, no bats flying by. And even out to 75 meters, we were seeing lower bat activity, meaning those little brown bats are impacted 75 meters away from a light and probably more. We only measured to 75. We didn't expect what we were perceiving as pitch black to be impacting these bats. So you think about putting up a light, and that bat has to fly over 75 meters away to like go around and avoid the impact of that light. Like that's a really big detour. And then you think about if you just have a small fragment of natural forest and you put up a light, it technically could make that entire small patch of forest unusable to a bat, even though we didn't even know that it was shining that far into the forest. So it just has this huge potential impact on our environments and how it degrades them and fragments them and essentially makes them unusable to some bat species. So while there are some that don't care, they're like, shine your lights, we'll eat those insects. There's some bat species that are going to be highly impacted. And that's a species like little brown bats that are also being highly impacted by white nose syndrome. So it's like this double whammy. It was out to 25 meters that we saw the overall community has changed. So you just figure like that community of bats that is there at the light and out to 25 meters is a different community than what you would be measuring or say was present in an area out at 50 and 75 meters. So there's like those that are gonna be happy dealing with the light and then those that are not. Um, and that has long-term impacts. So how do we deal with all of this? There's quite a few resources out there, and the first choice is to avoid putting out light. So when possible, don't turn on a light. If you do have to turn on a light, a part night lighting scheme is better. So this research looked at like if we only turn on the light for the first half of the night and then turn it off for the second half of the night, is that better than it just being on all night? And they found that it is better, but it depends on the species and their emergence time. So some species are late emerging light sensitive species. So they're going to wait until the sun is fully down and then they'll come out. It's still not going to help them, but for some of those other, or sorry, it will help them, but for some of those earlier emerging species, it doesn't help because the lights are still on. So it is better than nothing, but still not a solution. And then we can look into continuing to hone in on how we can change the lights that we put out so that they are low UV emitting light bulbs, they're red, and there's some really cool examples of entire communities doing this that I wanted to highlight. Not surprising, they are not in North America. They are in the UK and Sweden and the Netherlands and Denmark, also where a lot of this really impactful research is coming out of. But so they are kind of doing either community-wide lighting, neighborhood lighting to kind of specific nature path lighting because they found that bats were specifically avoiding kind of their typical flight routes. And so by changing these lights, that would have a benefit on the bats in their kind of more natural habitats. So it's pretty neat. All right. I have to touch on this. I know we don't have much time left, but just wanted to share some of our upcoming very new research that's going on at BCI that is light related. So it's a bit of a flip that We've talked about, I hope you know, the impact of wind turbines on bats, particularly migratory bats. Um, there are millions being killed annually by collision with turbines. And the problem is that we still don't know why. We still don't know why these bats are attracted to wind turbines. And one of the hypotheses that has been out there for a while, but not really rigorously tested, is that the bats are being attracted really far out, really when they're out on the landscape before they even get to the wind turbine facility by the aviation lights or these obstruction lighting that are these like red flashing lights. So if you're ever driving past them, you've seen just that you're out in the pitch black and you just have these flashing alien-like lights all around you on these turbines. They are required. It is for safety so that planes do not collide with wind turbines. They are important. But even the lights are not required to be on all night. They only have to be on when planes are a certain distance from them. So we have new research that's going on with our partners, and we're starting field work this fall to look at the role of this aviation lighting at attracting bats to the wind facilities, really from long distances. So just a sneak peek in some of the stuff we're going to be working on this year and the next 5 years, really. All right, and the last bit is what can you do in your day-to-day life to make a difference in this? And one thing that is very encouraging is you can plant trees. Just the impact of adding trees can be really beneficial. You know, these trees can be like a shade or a refuge from light for these organisms, both the insects and the bats. Um, and so really increased dense vegetation in urban areas and planting shrubs and trees in backyards to block light is one really actionable step and has many other benefits too. Another resource I recommend you check out is Dark Sky International. This is an incredible organization that is focused on restoring the nighttime environment and combating artificial light at night and this light pollution globally. There's regional chapters worldwide. They put on International Dark Sky Week every year. It'll be April 21st to 28th in 2025. So you can start planning now how you're going to get involved and make a difference for bats and yourselves. And I love this program that they have, which is their dark sky friendly home lighting program and these 5 lighting principles for responsible outdoor lighting. And they really touch on everything that I've already talked about. You know, only have lighting if it's necessary, if it's useful. If you do have to put up lights, make sure they're targeted and, you know, they have a limited area that they are reaching and that they're shielded so they don't kind of lighten up all this other area. They should be low level. They don't need to be brighter than necessary. You can control the timing, so have them be motion activated or on a timer so that they're not just on all night, only when needed. And then use warmer colors. So stay away from those cool colors with the shorter wavelengths and go from a warm white towards a red, and that'll have less of an impact on both insects and bats. So there's a lot to take in there and a lot that I even plan on doing at my own house to make a difference in this. And then for those of you who are real bat nerds out there, there's a ton of incredible research into this topic, which has been really nicely summarized in a couple publications. So Eurobats has this really great guidelines for bats and lighting projects that's available online as a PDF, and Bat Conservation Trust put on a artificial lighting symposium in 2019 and summarized all the new research that was highlighted there. So We all have things that we can do just to make, the small impact that we can in our day-to-day lives and the urban areas that we live in. But hopefully that'll all add up, and research will also continue to work towards finding a win-win solution so that we're really not pitting the environment against public safety, which tends to be the goal of artificial light at night. So we want to just do as much as we can to get back to having a dark sky and healthy habitat for our bats. So thank you everyone for joining me, and I look forward to seeing what you've been thinking about in this topic.
Absolutely. All right. Thanks so much, Amanda. So we've got time for questions. Go ahead and keep sharing them in the Q&A box. And so to kick us off, we've got a question from Lauren, who asks, is there a general mileage away from the highlight urban areas that you will find dark sky, or does it kind of vary?
Yeah, so I will be honest, this is a bit like the extent of diving into this topic on the broad level is new for me. I'm definitely on the bat side of things, being a bat nerd. My guess is that there is a distance that's been established kind of for especially major urban areas where you get to kind of these different Bortle scale levels, but I do not know what that mileage is. But I do recommend, I bet you could kind of dive into that very loosely if you go to the sky brightness atlas and zoom in, and you can like see how far away from that kind of urban sprawl till it really starts to drop off.
Okay, that makes sense. Harrison asks, what's the difference between thermal and infrared light in cameras, or what
Oh,
is
yeah, that's
camera?
great. So price, no, thermal is very expensive. They're used in different settings. I think the main thing is that IR is going to be picking up on light. So usually if you're using an IR camera, you're also projecting an IR light source to light up that area. So you're kind of limited to the area that you're able to illuminate with an IR light source, where thermal is based on heat put out by an organism, such as a hot little bat flying around. So it doesn't require like anything else to illuminate the area. So it can be pitch black, and it's just detecting that heat signature.
Okay. Got a question from YouTube for the Sea Wagon. Is that how it's pronounced?
Mhm.
Wagon et al. 2023 study about distance to light source. Do you know if that was in a fairly open environment or if it was a forested environment? And would you get a different result if you looked at very forested and cluttered versus an open field?
Great question. Yes, so it's kind of hard to see in this picture area. Um, and this is a natural area that isn't usually illuminated as well. So that was kind of a key part. These lights were a very novel, acute thing that were added just for this study and are no longer there. And so yeah, the fact that this was an open area, I think does make a difference. And that kind of goes to that point of that the setting that light is being shown in does have an impact. And trees can be beneficial because they are creating a bit of a natural light break. So I would imagine if you put those lights right at the edge of a forest, there's that light is still going to shine into the forest a ways, but it potentially will reduce the distance effect of those lights because the trees will kind of block that light to a certain extent.
Got it. Okay. Misty asks, does using motion sensor lights make a difference, or are bats gonna be picked up and just boom, blasted with light when they fly through.
Yeah. I mean, motion sensor lights are startling to everyone, aren't they?
Yeah.
Which is part of the beauty of them in your backyard at times. Yeah, so I think it kind of depends on the sensitivity of your motion sensor light. I think most bats are not going to be setting it off, and the probability that a bat is going to fly right by that window of detection is unlikely since they're typically positioned to pick up movement on the ground rather than from up in the sky. Theoretically, a bat could trigger a motion sensitive light, but I think that it's worth the risk or that low probability chance that they would set it off.
Got it. And then a follow-up question from Facebook. So solar lights, depending on what light they're giving off, aren't necessarily a an improvement if it's not a red light or a the right UV range, right?
Yeah, I think the question is asking about kind of light sources that are powered by solar energy, I
Hmm.
believe.
Yes.
And so at the end of the day, like any light bulb can be powered by solar energy. But it's going to tend to be LED since they have lower energy requirements. So doesn't the sun will be more likely to be able to power them. And yeah, it still will matter what kind of LED bulb it is, and you'd want to be aiming towards more of that warm white, if anything. And then also, if you can do a timer, I know there are some solar light fixtures that you can change if they're on for 4 hours, 6 hours, 8 hours, and try and put them for the shortest time period possible.
Okay, that makes sense. Yeah. And then a question from Frankie. Do light sensitive and light tolerant bat species generally interact with each other? Do you find them in the same habitats? Or are they often not even coming into contact with each other?
Yeah, I love that question, Frankie. I think there's definitely areas where, like in a kind of US North American sense, we'll definitely find silver-haired bats and big brown bats in the same area, or little brown bats and eastern red bats commuting through the same area. They're definitely going to be preferring different areas for where they're foraging. But then all bats also need to go to water sources. So they're all going to be converging on water sources where they can drink. Um, in other parts of the world, there's going to be a lot different makeups of those communities. And so there are studies out of Europe showing that those light averse and tolerant species in the same community quite frequently in a lot of their studies in unlit parts of their studies. Yeah. So you turn on the light and that light averse species is totally gone from the community when if the lights were off, it would be there.
Got it. Okay. And Sally would like to know, does BCI partner with Dark Sky International on any
Ah,
projects?
I know. We have. I don't know about our long history or the long history of both organizations. There is definitely a fantastic article on the impact of bats and lights that Dr. Kristen Lear worked with Dark Skies on for Bat Week 1 year. Um, so I know we have interacted, but I do not know the extent of our partnership. And trust me, I'll be looking into that and personally looking into my local Dark Sky International chapter to see how I can get involved. So cool.
Awesome. Yeah. And then maybe we can finish on this one. So Emily's asking, at this point in the research that's available, should Bat Fanatics start contacting their city planning and local, uh, town orgs about adopting red streetlights?
Yeah, I mean there is enough research out there to show that it will definitely have less of an impact than the white lights that we're using everywhere. There's cities that have already made switches to more of an amber light color, especially near kind of observatories and things to reduce that sky glow. But I think it is always a good thing to be reaching out and seeing what your voice can do in making a difference in this topic because it is for the bat fanatics. It is for even our own health and that of all the other wildlife and plants in our areas. Yeah, so it's something also I'd say like new developments. That's a place that I would hope we could make some really measurable differences. So yes, please spread the word. Make those changes at your house first, and then start looking outside your own properties and seeing what difference we can make in reducing those artificial light levels at night.
Awesome. Okay, well, thank you again for sharing this info on light pollution with us. Thank you to the audience for joining us. To learn more about our work, you can visit our website at batcon.org. If you're not already, subscribe to our mailing list and newsletter to learn about future webinars and the work that we're doing. This recording will be available on our YouTube channel. Just search at Bat Conservation on YouTube. Any final words for us, Amanda?
Yeah, I just want to thank everyone for being bat nerds and thinking about the impacts that you can make out there to make the environment better for our flying friends and for ourselves. So thanks for being here and asking all those fantastic questions.
Yeah, thank you. All right. So that's it for now. Thank you, everyone, for being eager to learn about bats, and we'll see you at the next Bat Chat. Bye.